Hi, my name is Jim Thompson, and I'm going to talk about the Equilon Refinery coking plant accident in November 1998. A truly bizarre and horrific accident which killed 6 people. Um, this accident's perhaps not as well known as it should be. My own background is 41 years in industry, including 25 in nuclear plant operations, design, engineering, and safety management, followed by 16 years in safety consultancy, uh, including working on oil platforms in the um, Indian Ocean, Black Sea, and North Sea. This accident killed 6 people, but despite that, it's not terribly well known. Um, the list of sources I've used is given there. The primary source should be the Washington State inquiry report, but that does not appear to be online. If anyone knows where it is, point me in the direction, please let me know. CSB published a brief note about it in a bulletin. NASA did a quite useful case study on it, and I've stolen some of their diagrams in this presentation. There's also, rather strangely, something on a website called historylink.org, and there's a technical presentation on it is also available, which goes into quantities and the heat of the oil that was lost and what have you. So there's a technical presentation and the bottom one of the 4 listed there, and the NASA presentation. They're the most useful, I would say. But if anyone knows the whereabouts of the Washington State report, please let me know. This is a Google Earth image of the plant, which is now owned and operated by Shell, with the coking plant in the foreground. I'm not sure how much has changed since '98. This is a 2020 image. The events leading up to the accident were that there was a storm in the early morning of November 24th, Tuesday, November 24th, 1998, which caused a power outage and a complete shutdown of the refinery. And that was partway through a charge cycle in drum A and the coking plant, which left about 200 cubic meters of hot coke and hydrocarbons trapped in the drum. And this occurred close to Thanksgiving US holiday, so it's possible. We should bear in mind that lack of support staff may have been significant in this, although as we'll see, that's by no means certain. I know you'll all be very familiar with the coke production process. This slide just tries to summarise it. Heavy oil into the coke drum, and cracking occurs to reduce the oil to coke and hydrocarbons, which go off for further processing. So coke production is obviously a batch process, and at the end of each batch the drum is cooled first with steam and water, and then once temperatures are low enough, work permits are issued and coke cutting is carried out. After unheading the drum, high pressure water used to cut up the coke, and it's then drained out the bottom of the drum into a pit below. So this shows the situation after the power failure. A part-filled drum, and the charge line was filled with clogged with coke and heavy oil, and that had to be cleared before they could make any progress. They couldn't get any steam in because of that blocked charge line, and that was a problem. Power and steam were restored after the grid failure about 10 AM in the morning, and the operators thought they'd got steam into the drum. However, it's likely that instead pressure relief valves were lifting and simply diverting steam into the blowdown system, so it's unlikely any steam actually got into the drum. This caused problems, as we'll see. Overnight, the night shift were told just to leave it alone. The drum was cooling without water, and day shift would unhead on the Wednesday morning. On the Wednesday morning, there were some impromptu meetings held to discuss what to do next, and initial attempts were made to clear the line into the drum without success. Conditions inside the drum were essentially unknown. Only temperature indications they had were nowhere near the bulk of the hot coke. Later estimates said it would have taken 200 days for the residue to cool down to a safe temperature. Anyway, in the afternoon of the 25th, the top head of the drum was removed without incident, and preparations were then made for removing the bottom head. And so, in the afternoon of the 25th, using hydraulic controls, employees lowered the bottom head while they were all standing underneath. 6 employees standing directly underneath. Slightly hard to believe this happened. So we're in the situation that a drum containing 200 cubic meters of hot coke and oil, they just removed the bottom of the drum while 6 people were standing directly underneath. And like everyone's reaction to that is, they did what? It's a bizarre accident. And what I want to do is talk about how this could have happened. So, how could this horrific and bizarre accident have happened? If we try and see it from the plant foreman's perspective, and this has got to be an element of guesswork, of conjecture, but unfortunately the foreman was killed, so we can't do it any other way. When the head was taken off the drum, he wouldn't have been able to see very much, I suspect. It'd be black on black and poor visibility, so he wouldn't have been able to see the oil level at all, I doubt, especially since it was so close to the bottom of the drum. Furthermore, he had no indication of high temperature in the drum. The only instrument on the drum was above the oil level, and the other instruments were on pipework outside the drum. So the only indication he had of temperature was that temperatures were reasonably low. He thought steam had passed into the drum, although it had probably gone to blowdown. So there seems to be 2 options. Either he thought that cooling had been achieved because of the steam, although that seems a bit far-fetched, it wasn't on for that long. Or the second option, which seems more plausible to me, was that he concluded the drum was empty. There was no high temperature indication, he couldn't see anything from the top. So my guess is that the foreman thought that grid loss had occurred before the charge cycle had properly started. Remembering that the grid loss happened on the night shift when he will not have been there. So whatever was in the log, we haven't had that. I haven't got any information about what was logged, but maybe the log was ambiguous. So I think he thought that the power loss had happened before the charge cycle had properly started, and the drum was therefore empty. One of the many uncertain aspects of this accident is the role of the night shift team. The power failure happened on night shift early in the morning of 24th November. So that night shift crew should have logged clearly that a lot of heavy oil had been transferred to drum A, and should have passed it on in the verbal handover as well. If it was the same night shift team, so i.e. if there wasn't a shift change on that day, then that same shift team had an opportunity the following night, on the morning of the 25th, to tell the day shift that drum A was full of heavy oil. So they got 2 bites at the cherry, as it were. They had 2 opportunities to tell day shift that drum A was full of oil. What was in the night shift log? I don't know. What was said in the handover? Well, we'll never know. From the plant manager's perspective, he'll have been overwhelmed by dealing with all sorts of things around the plant arising from the grid failure. So maybe he implied urgency to the foreman. Just get on with it. And maybe the foreman inferred that the manager had given him responsibility for getting on with it and didn't have to refer back to the manager. The outcome then was that oil spewed out in all directions, burst through a crust, and it was above auto ignition temperature. It caught fire, and all 6 workers were killed. You can see the green dots are estimates of their location at the time. A very unpleasant accident indeed. The photograph on the left shows the fire in progress. This is the only photograph, so far as I'm aware, of the accident. And the photograph on the right shows which was taken a couple of days later, gives some idea of the state of the plant underneath the drum. Oil and debris splattered everywhere. I've no knowledge of how quick the deaths were of the 6 workers who were killed. I hope it was quick, but it must have been, the cleanup process must have been traumatic for all involved. And it's one of those accidents you see, I just don't ever want to go there. One of the worst jobs any plant manager ever has is phoning up family to tell of an accident on plant. It's not something anybody ever wants to have to do. So, in the aftermath of the accident, the Washington state authorities set up an investigation that lasted 8 months. I haven't seen this report, but I've read that the root causes identified were: 1, the plant manager's decision to allow cooling for only 37 hours. 2, failure to train employees properly. And 3, inadequate management of change procedures. Equilon subsequently installed a remotely controlled system for removing the drum lids and installed a gas-fired backup system to maintain steam supplies in the event of power failure. As I say, I've never seen the Washington State report, and if anyone can point me in the direction of a copy of it, please get in touch. So what should have happened? They were well outside normal operating procedures. So some attempt should have been made to investigate the interior of the drum, possibly lowering measurement devices into the vessel, probably needing specialist contractors. And the plant manager should also have contacted specialist technical support. There would have been significant delays to operation had that happened. And if you ask, why did this happen? Well, design failure is the first reason. The plant should never have looked like this. Remote removal of the bottom head was introduced after the accident, but any basic safety analysis would have shown that improvements to head removal arrangements were a high priority. And also, the instrumentation was clearly inadequate. There was no real proper idea of temperatures near the bottom of the drum. The second reason is management of change failure. It appears that the foreman concluded that the charge cycle hadn't yet started at the time of grid loss, and therefore it was okay to remove the bottom head. Non-standard operating conditions should of course have indicated a need for a timeout for managerial and technical review via the management to change process. Perhaps the foreman thought he had delegated authority. Contributory factors could have included, well, the obvious one: Thanksgiving holiday, a shortage of support staff and advice. Secondly, cost and time pressure, actual or perceived. Did the foreman think he was being rushed to get on with this? And last one, was the coking plant regarded as a Cinderella, unsexy, getting minimal attention from management and technical support staff? Did the coking plant guys just get on with it, and were they largely ignored? Total costs to Equilon were about $50 million. This included a legal fee charge, settlement package, design improvements, and most significantly a $45 million settlement in a civil case brought by the families of the 6 dead men. So this was a very expensive accident for Equilon, quite rightly so. And here are the names of the 6 dead men. I guess many of them will have been family men with children, and all the difficulties that will have produced. Summary then. I guess all accidents tend to look bizarre with perfect hindsight, but this accident seems to me to be exceptionally bizarre. and we'll never know exactly why it happened because the foreman was killed. It does feel like no modern standards safety analysis had been carried out on the plant as built, because the removal of the bottom head of the drum was clearly a safety critical process. The factors that are significant seem to be poor design, the lack of a remote head removal equipment, weak management of change, especially following a power loss incident, which is an entirely design basis condition. There should have been procedures in place for how to deal with all the circumstances following a power loss. And then the lesser factors that we don't really know about. Thanksgiving holiday, does it mean that there wasn't help available that might otherwise have been? Time pressure, did the foreman perceive that he was under pressure to crack on with this and get the plant running again? And then the last one, which is the most subtle one really, was the coking plant regarded as a relatively unimportant part of the plant, low risk part of the plant that management did not pay adequate attention to, and perhaps technical staff didn't pay adequate attention to either. The last three are ones that we'll never really know the answer to. However, there are press reports from the civil lawsuit which concluded in 2001 out of court. The lawyer for the families, it says here in the Seattle Times, 20th January 2001, the lawyer for the families, a guy called David Benninger, introduced evidence that refinery supervisors were following a management philosophy that promoted fear as a motivational tool and encouraged workers' ongoing risk-taking in order to increase production. How much weight you can put in this is, of course, open to question. Any lawyer in this sort of case is bound to say something like that. But it does sort of lead some strength to the argument that the coking plant at least was being neglected. This accident is really one of the most egregious, most exceptional accidents I think I've come across, and I think we're obliged to remind ourselves of these events, just how easy it is for people to come unstuck, to do things that appear daft, crazy, when abnormal plant conditions arise. Accidents are avoidable.